Every day, billions of your cells kill themselves. It isn't damage, it's a program. Cells that are old, infected, or no longer needed run a clean, controlled self-destruction called apoptosis. The cell switches on a set of internal blades, enzymes called caspases, that take it apart from the inside. It shrinks, its surface blisters, and its own DNA is chopped into pieces. For decades, this was considered the ultimate one-way door. Once the executioners were loose and the DNA was breaking, the cell was gone. Except sometimes it isn't. In 2012, biologists watching cells die saw something that was not supposed to happen. They pushed cells deep into apoptosis, caspases active, the machinery running, DNA already fragmenting, and then they took the death signal away, and the cells stopped. They pulled themselves back together, repaired the damage, and went on living. The researchers named it anastasis, Greek for rising to life. This is not a cell hesitating at the threshold. These cells were well across it. They had switched on the tools of their own demolition and begun cutting their own genome, and still they reversed course. The point of no return, it turned out, sits much later than anyone believed. And for a cell that reaches it and comes back, the whole idea of a single moment of death starts to blur. There is a good reason a cell might want this. Some of your cells are almost impossible to replace. Your heart muscle, the neurons in your brain, you are born with most of them and you do not grow more. If one begins to die during a passing crisis, a shortage of oxygen, a jolt of stress, and can climb back out before the end, that is a cell you get to keep. A rescue you would never know happened. But there is a shadow. A cell that has started to die is a damaged cell. Its DNA has been cut. In pulling itself back together, it can stitch that genome up wrong. And a cell that returns carrying broken, rearranged DNA can return dangerous. In the lab, some cells that survived this process didn't just recover, they picked up the kinds of mutations that push a cell toward cancer. Researchers suspect anastasis may be one way a tumor cell survives the chemotherapy meant to trigger its death. Playing dead, then coming back, harder to kill than before. How much this drives cancer in a living body is still an open question. But the possibility is unsettling. The same trick that could save an irreplaceable neuron might let a cancer cell cheat its own execution. So the tidy picture, a cell decides to die and dies, is wrong. Death, at the scale of a single cell, is not a line. It is a process, and it has a rewind. The cell that comes back is not quite the one that left. It carries the scars of where it went. And somewhere in your body, right now, a cell that began to die may be quietly deciding not to.